Hello guys, welcome back to the physics revision. So let me continue. So I answered this one, I think. Then here they say explain why. In practice, the actual acceleration for the object may be lower than your answer to A party to above. So this is due to friction. You say this is due to friction force. Okay, so let's move. Here they say define work and power. So you say work, you say this is the product of force, and distance moved in the direction of the force. So this is how we define work actually in simple. Or you can say it is the transfer of energy. You can say, or work is the transfer of energy. Okay, so otherwise this is the fundamental. So work, this is the product of force and the distance moved in the direction of the force. Okay, so when a force is applied on an object, then an object moves in the direction of the force, then work can be said to be done by the force. Then power, we are saying power, this is the rate at which work is done. You can also say it is the rate at which energy is transferred. So, or we're going to say it is the rate at which energy is transferred. Okay, so this is work. I mean power. So in physics, when we are talking of power, we are just comparing energy transfer within a specific period of time. Like, let's say you have given two people to cut same size of trees. Then if this person finishes the cutting of the tree within a short period of time, then that person will be said to be more powerful, even if the body seems to be very, very slim. Okay, that's what physics is all about. Power is just how quick work is done or how quick energy is transferred. So here they're saying a pupil of mass 50 kg runs up a flight of 20 stairs, each 25 centimeters high, in a time of 20 seconds. Take G to be 10 Newton per kilogram. Then they say calculate part 1, the pupils gain in potential energy. So they just want potential energy of the pupil. So potential energy, as we have seen already now, we are getting familiar now. That's the importance of revising. Okay, so potential energy is M, G, and H. Then we have been told M is mass, right? So M is mass, which is 50 kg, all right? Then G, we have been told it's 10 Newton per kg. Then this H, okay, H should be, so these are stairs, so they're supposed to be 20 stairs, each is 25 centimeters. So you say 20, okay, times 25 centimeters. What are we going to get? So let me get my calculator as usual. So each one of you should buy a calculator, guys. Physics, we are allowed to use calculators, and also in chemistry. So 20 times 25, what are we getting? 500. Now this one will be in centimeters, okay? So it will be like 500, okay, centimeters. Now we need to convert height, should be in meters, so we divide by 100 so that it becomes 100 into 500, it will be 5. So this will be meters. So then we'll substitute, so it will be equal to m, it will be 50, so we'll put 50 kg, okay, times then 10 is 10 newton per kg, okay, then times h is 5 meters. So we'll now do a quick multiplication again, okay? So here we'll have 50 times 10 times 5, which will be 2,500. So 2,500 joules. That will be the potential energy. So you put here 2,500 joules. Don't forget the units, guys. Then they say here we are calculating the useful power developed by the people in climbing the stairs. So power now, as I told you, power now will just convert it. Power is equal to work, right? This is the formula, work over time. Now work is going to be equal to potential energy, because work is the transfer of energy. So in this case, it will be potential energy. So here we'll just put potential energy over time, which will be equal to our potential energy. We have found it's already to 5, right? Over time. What is the time? So the time was 20 seconds. So 20 seconds, which means power is going to be what? So let's get our calculator. So we are having 2,500 divided by 20. We are getting 125. Okay. You see, so we are getting 125. So the units for power are watts, W. So you put here 125 watts. You see? Oh, sorry. How was it to move this so fast? Okay. Yeah, so that's the answer. Then we come to the next question, B. This one was, okay. So this one came, I think, in the same year, right? Yeah. So this one was part B. Figure 11.1 shows a uniform meter rule balanced horizontally on a knife edge placed at the 50 centimeter mark when a mass of 20 grams is suspended from the end. Okay, so a meter rule, as usual, that is balanced horizontally on a knife. So we conclude this is a pivot, which is a knife. Okay, then placed at 58 centimeters. Yeah, so it is at 58, meaning from this point to that point, it's 58 centimeters. Okay, so let me see the next part. Okay, so let me create space, guys, here. Okay, where I'm going to solve from. So yeah, then we have mark when a mass of 20 grams here is suspended from the end at that point. Then part 1, they say find the mass of the rule. So this ruler, the mass. So the mass of the ruler, guys, is always at the center. So the center of the ruler is maybe somewhere where they've placed though, but it should be at 50. So going this side, it should be 50. Okay, it should be 50. Going this side, it should be 50 centimeters. And then going this side, it should be 50 centimeters. Okay, so at this point at the center from the look of things, it is where they've put here, but they're saying this is 58. So as we'll say, okay, the center, let's say it's here, the center of the ruler, and that's where its mass is, and its mass is acting downward, the mass of the ruler. Okay, that's the one they are looking for. So since this one is balanced horizontally, it means the weight, the mass, and this mass, they are balanced, and because of that, meaning this thing is in equilibrium and the principle of moment is going to apply. So using the principle of moment, which will be moment on the left, the moment which is produced by this mass should be equal to the moment on the right, which is the moment caused by this. So this is making it to rotate in the clockwise, or yeah, it's acting on the right, then this one is acting on the left side. Okay, so but they are balanced, meaning they are equal, that's why they are balanced. Then but this side, it should be the mass, okay, mass times a distance of the mass. Okay, then also this side, it should be also the mass provided. So mass on the left times distance on the left, here it will be mass on the right times distance on the right. Then so now this mass, we don't know it, so just put m. Okay, so m times this distance now is this distance at which mass is acting from the pivot. So this distance here. So I've told you that we need to know this distance, but from here to here is 50. But for us to know here, we'll say 58 minus 50, which will be, this distance will be just 80 centimeters. Then this distance, again from here, we need to know it. So here I've said it will be 8 is equal to, then mass, it is already 20, so put 20 there times, then this distance here, which is from the pivot to where the mass is. So for us to know this one, since this is at 50, so it will just be like 100 minus 58, which is going to be 42, right, if not mistaken. So this one will be 42. Okay, so now we are going to multiply this. So let me just put this one here. Okay, so this is part B, part 2, okay, part 1, B part 1, B part 1, yeah. So, so I've said it will be M times 8 then is equal to 20 times 40, 2, which will mean that this times this will be like 8m is equal to, so for 20 times 42, right? Yeah, 20 times 42. So 20 times 42, 840, right? So it is giving us 80, 40. Then we want m, not 8, so divide by 8, so that 8 goes, we remain with m. So this 8 and that goes, then we remain with m is equal to, so then we are going to divide 80, 40 by 8. So this 840 divided by 8 will get 105. So the mass will be 105 grams, like that. Then we come to B. They're saying, what is the weight of the ruler? Oh, if we find the mass, then the weight will be simple. You know, so part 2, you know, weight is going to be equal to mass times the acceleration due to gravity. And mass we have already found 105 grams. Now, except this one should be converted into kg by dividing by 1000, so that it will be 0.105 kg. Then acceleration due to gravity is 10 Newton per kilogram. So then weight is what we are looking for, question mark. Then we'll substitute, which will be equal to, so where there is mass, we'll put 0.105 kg. times where there's mass, I mean gravity, we'll put 10 Newton per kg. So kg and kg will go, then we'll multiply 0.105 times 10, it will be like 1.05 Newton. That will be the weight, guys. Okay, then that will be the weight. So let's move to the next one. Okay, this one, no? Yeah, this one. So here 5 says a body has a mass of 2 kg. It accelerates from 20 meters per second to 40 meters per second in 4 seconds. The resultant force is, so they want force, so say force is equal to mass times the acceleration. Then mass they've given us, it is 2 kg. Now acceleration is not known, but they've given us the clue that a body has a mass of 2 kg. It accelerates from. So from becomes initial velocity, 2 becomes final. So this is the initial, this is final. In 4 seconds, this one becomes time. So meaning we'll calculate acceleration from this formula. Final, what's going on? Final minus initial over time. So pick our final, which is 40 minus initial, which is 20 over time, which is 4 seconds. Okay, so we are going to divide or subtract 40 minus 20, it will be 20 over 4. Okay, so 4 into 20, it will be 5. So this will be acceleration 5 meters per second square. So this acceleration will substitute now to find the force. So mass will be, so now before that acceleration is already found, it will be 5 meters per second square. Now we can substitute mass is 2 kg, so 2 times acceleration is 5, so put 5, 2 times 5, it will be 10 Newton. That is the force. So the answer will be B. Then here a force of 500 Newton is applied to a box in the direction shown to move it up an incline. So a force, this one here, is applied to a box in the direction shown to move it up an incline. Okay, so this is an incline from simple machine. So we have a force that is moving a box in that direction. The length of an incline, or the distance that this box moves, is from here up to here, which is 5 meters. All right, then this is the height of the incline plane. Then they say it takes 3 seconds to move this box from R to S, from R to S. The useful power generated is, okay, so power is equal to work done over time. So now the useful power generated, there are 2 types of power here. There's power input and then power output. Okay, so the power output, it's the potential energy. It will be like the potential energy. So power output is what is benefited, and that's what makes people to get confused. So power output is the work done in moving this. So this would have been at the original position of 0 at the ground. Now it will be at the final level of this. So that will be the useful power generated. Okay, so it will be based on this calculation from the level down to the level up. So this work now becomes, now it will be potential energy. So potential energy, let's find potential energy. Okay, potential energy, I'll just substitute the formula. Potential energy is mgh. So meaning in this equation, I'll just put, where there's work, I'll quickly put mgh, because work is potential energy, and potential energy is that over time. So now I'll quickly say equals mass of the box. Oh, so if the mass of the box is not given, then we can also calculate, the mass of the box if we want, using this one. Weight is equal to mass times acceleration due to gravity. So mass here, making the subject of the formula, will divide by g. Here also g, so that g cancels, we remain with mass. Mass is going to be weight over g. So which is going to be weight is this one here, 500. Oh, sorry. So we haven't even provided the weight of the box. So in that case, we'll just ignore this part. Okay. So now, if it is in that case, we'll not use this. So it will just change automatically to this. So it will change automatically because the box, nothing has been provided on it. So meaning the work that is going to work here, we'll use this formula here, this same force and the distance here. Okay, so follow this distance. So work is going to be work, you know, now it will be force times distance, meaning here where there's work, we'll put force times what? Distance over time. So the force is this one here, which is 500 Newton. The distance the box moves is 5. So put 5 over the time we have been told 3 seconds. So put 3 seconds there. So which is going to give us, let me just do this. So we have 500 times 5 equals that one divided by 3. Which will be 83.3. 83.3. Okay, I think it will be 833.3, which will be watts. So the answer should be, I think, C here. So we move. So this one 8 says the figure below shows an ideal pulley. Oh, so this one is like the one which came. So remember, in an ideal pulley, I told you that efficiency is 100%. Okay, so when the pulley is an ideal, then efficiency is 100. Okay, so then they say assuming G to be that the minimum effort required to raise the load is, this question will be a bit tricky, but let's see. So in this case, first of all, we'll find the mechanical advantage. So mechanical advantage is going to be equal to velocity ratio. So the mechanical advantage, if in such a case when efficiency is 100, meaning mechanical advantage is equal to velocity ratio, and velocity ratio is equal to the number of strings connecting the upper pulleys and the lower. So here the number of strings are 1, 2, 3, 4, 5. So velocity ratio is equal to 5, meaning mechanical advantage is also equal to 5. Now, the question is asking the minimum effort required to raise the load is. So here you use mechanical advantage. Mechanical advantage is equal to load over effort. Okay, that's how it is going to be. So now, because of that, so load you have been provided, it is this one, 500. Now you should convert a 55 kg, convert it into what? Into force or weight. So it will be like load to convert it in kg to convert it into force. It will be like weight. We are converting weight, which is mg. That's why they gave us this. So it will be equal to like 5 times 10. G is 10. 5 is mass, this one here, which will be equal to 50 newtons. So here now, mechanical advantage will put 5, okay, is equal to load, it is going to be 50 newton over effort, E will not know it, then we'll make the subject of the formula. So we'll say over, we'll cross multiply. So 5 times E, it will be 5 E. 1 times 50, it is going to be equal to 50. So divide by 5, even here by 5, so that goes here. So E is going to be 5 into 50. It is going to be what? 10. Okay. All right. So meaning that will be the effort. So our answer is going to be D here. Okay. So we move to the next question. Okay. So this one came in 2013. A car of mass. No, these ones I was saying I already did them. Okay. Okay, we come to this one, which came also in 2013. So it says figure 4.1 below shows a door well secured on the door frame. Okay, this is the door well secured on the door frame. Then they're saying, what is meant by moment of a force? So you say the moment of the force is the turning effect of a force about a point. This is n. So that's what the moment is. Then they say include its SI unit. So you say its SI unit is the Newton meter. You can put even in brackets Newton meter like that, you forget. Then you come to be the saying B. Calculate the moment of force if a force of 10 Newton is applied at point 1 to open a or close the door. So we are calculating the moment if a force of 10 Newton is applied at point 1 to open or close the door. So you come here, you check. So you have been provided, this is a door, and this is these 2 points here are the hinges. Okay, hinges. So the hinges becomes the pivot, the points at which the rotation of the door happens. Now they're saying you calculate the moment if because this is point 1 and point 2. So they're saying we calculate the moment if a force is applied at this point here. You as a person, you stand here. Okay, you are opening the door. Okay, maybe this is a human being opening the door, pushing it at this point here so that the door can open. So this is your point of application of force, and the force that I've told you that it's 10 Newton. So now what will be the moment? The moment if you apply there. So remember I said that moment, which is represented by m, is equal to force times distance. Okay, perpendicular distance. So force, we have been told it is 10 Newton, then times distance. So distance, if the application of the force would be here, the distance of the force, it should be the distance of the force from the pivot here, which is the hinges. So you see the distance is this 0.5 plus 2.5. So if we say 0.25, what's this now? 0.25 meters, this one here, plus 0.50 meters, this one. So it will be meters 5, this one will be 7.0. So the distance from here up to here total is 7.0. So you come here, so the distance will be 0.7 what? I said 7.5, not 7.0, 7.5 meters. So you are going to multiply 10 times that, it is going to be equal to 7.5. Then you put Newton, then meters as the unit for moment. So it says 7.5 Newton meters, if I've not made a mistake. Then see, they're saying explain why it is easier to open or close the door if the handle is fixed at point A than at point 2 or 3. So they're saying you explain why it is easier to open or close the door when the handle is placed at point 1 here than at point 2 or 3. So you see that moment depends on distance from the pivot. So you say because at point A, the distance from the pivot is larger than when at point 2 and 3. Okay, so I say because moment depends on distance from the pivot to the point of action of the force and at point 1 distance is larger than at point 2 or 3. So you leave it like that. Then we move to the next question. This question also came in the same year, and also they brought question 4 moments at this one. Figure 5.1 below shows a simple bottle opener made by fixing 2 screws into a piece of wood. Okay, this is an opener made by fixing 2 screws into the piece of wood. I can only see 1 screw anyway. Here I think this is a screw. So now this is the wood. I think this one is the bottle opener, I think Z or what. Then this is the point there, bottle. Then A, they're saying what is meant by a simple machine. Okay, so say a simple machine is a device by means of which look at that, by means of which work is done easily by applying a force at one point to overcome a load at some other point. So this is the standard definition of a simple machine. So we move. B, they're saying which of the points X, Y, or Z is the pivot. So in this case, if they're using this thing to open, this will lock there. Then a person can hold from here and take it there so that this can knock out that. So then this one becomes the pivot there. So X. So we are saying X is the pivot. Okay. Then effort. So effort will be at here. I told you Z. So Z is point of application of effort. Okay, then C is the force applied at X less or greater than the force applied at Z. So the force applied at X here, okay, because when you push this one here, definitely this one will also push a force there. So is it greater or lesser? So I can tell you that it is supposed to be equal, but because of friction somewhere here, it is going to be lesser. Yeah, so you're going to say the force is going to be lesser. The force is going to be lesser at X than at Z. Then D, state one modification that should be made on the design of the bottle opener so that less effort is used to open the bottle. So one modification can be by using a longer handle. So the handle should be just increased in length. So say the handle should be increased in length. Why? Because when the handle is increased in length, there will be more distance from the point of application of force to the point of to the pivot, and that will multiply the force. Then we move. This one came in 2014 on 6th June. So here they're saying a uniform meter rule is balanced when 100-gram mass on the left side hangs 35 centimeters from the pivot, and y-gram mass hangs 25 centimeters from the pivot on the right side, as shown in figure 2.1. So now what we are going to say is, okay, let me read again. A uniform meter rule is balanced when 100-gram mass on the left side hangs at 25 centimeters from the pivot, and a y-gram mass hangs 25 centimeters from the pivot on the right side, as shown in figure 2.1. Okay, so we are told a uniform meter rule, this one is balanced when 100-gram mass on the left side is hung at what? 35 centimeters from the pivot, and we have a y-gram mass hung at 25 centimeters from the pivot here. Okay, on the right side as shown. Then they say calculate y. So like the mass y here. So since the balance principle of moment will apply, so I told you that it will be moment on the left, which is this side left. This is the left, is going to be equal to moment on the right, which is this side. So moment on the right. So moment on the left is going to be this mass provided, which is m on the left times the distance of this mass from the pivot, which will be d left, equals then mass on the right, okay, mass on the right times the distance of this mass from the pivot, which will be d. All right, then we'll substitute ml, which is mass on the left, it is 100 times distance is this same one here, 35. Okay, 35, which is going to be equal to m. We don't know, so you just put y here, then times, then the distance from here to where y is 25. Now notice here I'm using centimeters and I'm not converting them, because when I'm using principle of moment I will not convert, because I know that the units will cancel out. So here when I multiply this times that, it will be like 3,500 equals this times that, it will be like 25y. Then I want y, not 25, so I'll divide by 25 so that it goes even here by 25, so that I remain with now y is going to be equal to, so I'm going to get my calculator as usual. So I'll say 3,500 divided by 25 to get 140. So our y is going to be 140. Now it will be grams, because the units are grams. Then we'll move to the next one. So that one was the only part here. Okay, and they're saying total 2 marks. Then we come to this one. They're saying a machine raises a load of 600 Newton through a height of 1.5 meters when an effort of 100 Newton moves a total distance of 20 meters. Okay, so a machine raises a load through a distance of 1.5 meters when an effort of 100 newtons moves a total distance of 20 meters. Then they say, calculate the work done in raising the load. So work is going to be equal to force times distance. So now, a machine raises a load of that through a distance of that. So now this is the load. The work done on the load will be this force, which is the load itself, times calculate the work done on the load. Yes, times the distance moved by the load. So it will be like 600 times the distance 1.5, which is going to be, if I'm not mistaken, yeah, I think this is, yeah, this is correct. So it will be now like 600 times 1.5, which is going to be 900. So it will be 900 joules as the work here done. Then here they're saying, what is the mechanical advantage of the machine? So mechanical advantage is equal to load, okay, over effort. So load, you have been told it is this one here, 600 Newton, and then effort, you have been told it is this 100 Newton. Okay, so this Newton and this Newton will cancel. So meaning mechanical advantage will become 100 into 600, it will be 6. So it has no units, okay? Then let me clean this part. Then here they're saying we calculate the efficiency. Okay, so efficiency should be equal to mechanical advantage over velocity ratio times 100%. So velocity ratio is equal to distance moved by effort over distance moved by load. So the effort moved this distance of 20, okay, meters. Then the load moved this distance of 1.5. So this is 1.5 meters. So that and that will cancel. So I'll say, okay, 20 divided by 1.5. We are getting something like 13. So here to be like 13, okay, as the velocity ratio. So now we'll come to substitute, okay. So say, okay, equals mechanical advantage will be like 6 over velocity ratio like 13 times 100%. So meaning our efficiency now is going to be equal to, so we'll get our calculator as usual, and then say 6 divided by 13 equals, that will be the then times this 100. So I'm going to say times 100. So it is going to be 46.15. So efficiency, it is going to be 46.15%. You put percent as the answer. Then we move to the next question, or this one, no? Probably this one we are going to answer it. Here they're saying a number of forces are acting on a body as shown in the diagram below. Then they're saying what is the magnitude of the resultant force acting on the body. So there is a force acting this direction, which is the 20 Newton. Another force acting in that direction, which is the 24 Newton. Then a force acting in that direction, which means 13. Then this one acting in that direction, it is going to be 10. So meaning this and this will subtract each other. So we'll have this force going in this way, which will be PC. Come, you sleep. Come, sleep. So this one, the 13 minus 10, there'll be a force going in this way, which will be like 3 Newton, 3 Newton, 3 Newton here, 3 Newton. Then this force going up here will subtract this one, there'll be K4. So there'll be like a K4 going in that, okay. So here there's a 4 Newton going in that. Now the resultant force acts in the diagonal like that. So the resultant force will act in the diagonal. So force resultant will be here. So it will be now like, so this force here is the same as here. So it will form like, this force is the same as acting here. So it will be like a triangle. So we'll use here this force which is here. It's the same as it is here as well. So now this is now the other force. So we want this. So it will be like a triangle, and we'll use what we call the Pythagoras theorem. So this FR, the resultant force, is going to be this force going here, which is 3. We'll put squared plus this force going here, which is 4 squared. Then we'll square root like that. So this one will be like 9 plus 3 squared 9. Then what? Then 4 squared, it will be like 16. Okay. Then square root. Then 9 plus 16, that is going to be like 25. Okay. Then square root. 25 square root, it is going to be 5. So that will be the force, the resultant force. Okay. Then this one says a toy car of mass 600 Newton, a toy car of mass 600 gram moves through 6 meters in 2 seconds. Okay, and they're saying the average kinetic energy of the toy car is good. So kinetic energy, guys, which is E, is the energy possessed by an object due to its motion. So motion is movement. So meaning that objects that are moving, a car moving, a bird flying, a stone through catapult, a bullet moving, all those that things are moving. On a bicycle you are running, you have kinetic energy. All right. So they're saying a toy car of mass, that one moves through 6 meters in 2 seconds. The average kinetic energy of the toy car is, so meaning because it is moving, it has kinetic energy, and the formula for kinetic energy is equal to half times mass times velocity squared. Okay, you have seen it there. So now we have been given the mass, then we haven't been given the velocity. Okay, so now here velocity is the same as distance or displacement over time. So distance is 6. So substitute here, we'll have 6 over time, which is 2. Okay, so meaning 2 into 6, it will be 3 meters per second. That will be velocity here. So substitute 1 over 2 times this m is the mass here, 600. So this 600 as the mass in grams, it should be in kg. So we divide by 1000 for it to be in kg. So it will be 0.6 kg. So here it will be 0.6 times now the velocity, this one here, 3 squared. So meaning it will be like 3 squared, which will be 9. 9 times 0, 6. So we'll say 3 squared, it will be like 9 times now 0 0.6. 0 0.6. Not like that. 0 0.6 equals now divided by a 2 here, this down here. So we'll say divided by 2 to be 2.7. So the answer here to be 2.7. Now it is in joules kinetic energy. So the answer will be C. Then we'll move. So then this 7 says the diagram below shows an inclined plane used to lift a load of 200 newtons. So there's a load of 200 being lifted there. Then they're saying what is the velocity ratio of the inclined plane as a simple machine. Okay, so velocity ratio of the inclined plane, this is an inclined plane, is equal to length of the inclined plane inclined plane over height, this height here, height of inclined plane. So this is the formula. So length of the inclined plane is 100. So substitute length is 100 meters over height is 50. Okay, meters. So meters and meters will cancel. So 50 into 100, it will be 2. So that will be the velocity ratio. It has no units. So the answer will be C. We will move. This one not already covered. Then we'll come to this one also. So the saying figure 3.1 shows the inclined plane whose efficiency is to be tested. The force needed to raise a 35 kg trolley up the incline was found to be 140 Newton. The length of the inclined plane was 4.5 meters. Okay. Then they're saying A, how much useful work was done to raise the trolley to the top of the inclined plane. So now, as I said in the other one, so the useful work is going to be equal to um um like potential energy in this case. That's what I mean, because this trolley, when it is moved from here up to there, so the actual work that will be done is by moving it from this level, it will be to another level there. So meaning the useful work is done in the vertical direction. Okay. So meaning it will be equal to potential energy, which is equal to mgh. Then the mass of this trolley, we are told it is 35. So you put 35 times g. Even when it is not given, we should know always that it is 10. Then times height here. H is the height in this direction, 1.2. So let me see what we are going to have. So we are going to have like 35 times 10 times 1.2, which is going to be 420. So here we'll have 420 joules. So this will be the one, 420 joules. Then we come to this one. He's saying how much work was done by the effort to raise the trolley up the incline. So now the work done by the effort is now this one here. The effort moved through this distance. So its work done is this distance here, which we are told it's 4.5. So here the work is going to be now force times the distance moved by the force. So the force, it is going to be, we are told, which force? We are told up the incline was found to be, they're saying the force needed to raise a 35 kg trolley up the incline was found to be that is the force. So now the force, we know it is 140. So it will be 140 times what? This distance, which is 4.2. You will bring, which is 4.5. So it will be 4.5. So we'll come to our calculator. So we'll send 140 times 4.5, which is giving us a 360. So this, 630. So it will be 630 like that, joules. So here it will be 630 joules. Now here they say calculate the efficiency of the inclined plane. So efficiency has got a main formula. So it will be like work output over work input times 100%. So this one becomes the work output. The useful work done to raise that one there, it becomes the work. The one we found here, it becomes like the potential energy becomes the work output. The one we find here becomes the work input. So it would be equal to now the one we found here, which is 420. So 420 joules over this one we have found here is the work output input, which is 630 joules, then times 100%. Then we are going to divide. So I'll get a calculator. So I'll say 420 divided by 630, which is going to be 66, then times 100 times 100. So it is going to be equal to 66.7. So it will be 66.7% as the efficiency. So 66.7%. Then we move to the next. So this one says, let me provide the space here, guys. So, and we are on slide 55. We are supposed to go to slide 142 according to the work I had to put here. So this one is a lot. So let me provide the space here. So we are on slide 55. So now here they're saying describe an experiment you'd carry to determine the center of mass of a thin irregular shape. We already passed this one. Then here B figure 10.1 shows a uniform meter rule. It is pivoted on the 40 centimeter mark and balances when an object of 150 hangs on the 20 centimeter mark. Okay, so we have a uniform meter rule as usual, pivoted at or on the 40 centimeter mark here, 40 centimeter mark, and balances when an object of mass, an object of 150 Newton, hangs on the 20 centimeter mark here. Okay, then here they've indicated something else, and they're like that. Then they say calculate the weight W of the meter rule. Okay, so this is a meter rule from here to there. It is 100. Now the weight of the meter rule acts through the center, and I've now this time around indicated where it is acting through the center, which is at the middle. So meaning this side it is 50 centimeter, this side 50 centimeters. So now if this is balanced, so the weight of the ruler and this 150 Newton, they are balanced. So this one is causing the clockwise moment on the right. So this one will give us the moment on the right. Then this one is on the left of the pivot. So it is giving us the moment on the left. So these two are balanced. So meaning moment on the left is equal to moment on the right. So now I'm going to solve through this space I've provided here. So I'll say, what is this question number B? Okay, B part 1. So I'll say B, okay, part 1, I'm saying moment on the left should be equal to moment on the right. And then moment on the left, since we have been provided the force, this is the force, 150 Newton. So it would be like force on the left times distance of the force on the left from the pivot is equal to, then the weight on the right also, it will be W, the weight on the right, which is also force. Weight is also force. So I'm going to just use force here. Okay. So it will be force on the right times the distance of the force from the pivot. So on the right. So here we discover that the distance of this force from the pivot is, to say, 40 minus 20. So here it will be also 20. So the distance is 20 centimeter from there to there. Then the distance here from here to there, we'll say 50 minus 40, then it will be 10. So here we have 10 centimeter from here to there. So 20, 10 here. But here we have 50, here W we don't know. So we'll come back and say here we have the actual force is 150 times here the distance on the left. We have seen that this is 20 equals this force, it is the weight, we don't know it, then times this dr is 10. So I'll start multiplying now. Shh. So we'll say okay, this 150 times 20, it is going to be 3,000. Okay, so 3,000 is going to be 10 w times 10, it will be like 10 w. So we want w, so divide by 10, also here by 10. So this one will go, so this one and this one will go, so 1 into 300, it will be 300, I think, w. So let me see what I have on my calculator now. Okay, so meaning weight now, the weight now is going to be equal to 300 Newton, weight of the ruler. Now we come back to this question, part 2. Explain why the meter rule balances horizontally as shown above. So why it balances at like that? Because it acts at a certain distance from the pivot. So I say because part 2, because the weight produces a clockwise it produces a clockwise moment on the pivot located at so the pivot is located at what? At 40 centimeters. At 40 centimeters mark. Then we come back to this. See, they're saying explain why a high jumper can jump through a greater vertical distance on the moon than on Earth. Okay, this one it's not on this part, but because the force of gravity is lesser on the moon than on Earth. So we move this one, no. You see this one. Okay, a 4 kg brick is dropped from the top of a building whose height is 30 centimeters. The brick reaches the ground with a velocity of so there are two types of formulas that we need to know. V squared is equal to U squared plus 2 G height. So they're telling you that there's a brick of 4 kg that has been dropped from the top of a building whose height is 30 meters. Then they're saying the brick reaches the ground with the velocity of, so use this formula here. So you say V is final initial. Since it is dropping, meaning it started from initial 0, they want V. So V squared is going to be, here you have 0 plus 2 times, here is acceleration due to gravity, which is 10. Here height is 30. So you put 30 there. So V squared V squared is equal to, so you multiply 30 times 30 times 10, which will be 300 times 2, 600. Okay, 600. So now to get rid of the square, you square root. Also here you square root. So this and this square cancels with that. So V remains. So you square root now 600. Okay, so square root 600. Let's say okay, 600. Then square root. What are we getting? 24. Okay. 24. Now, 0.5. I happen not to see the answer here, right? So here there was no answer. They made a mistake. They never put the answer there. Because this is 2 times 10 times 30. Yeah, 600. Then the square root of 600. It is 24. So it's supposed to be 24 meters per second. Now let me use the kinetic energy formula. So kinetic potential energy at the top is equal to kinetic energy at the bottom. So the stone, before it is dropped, it has potential energy. So I'll find its potential energy as equal to mgh. Then the mass it has is 44, times gravity 10 times height, which is 30. So let's see what is going to have here. So it is 4 times 10 times 30. So it will be okay, it will be 1200 as potential energy. Potential energy is 1200 joules. Now this potential energy at the top before the stone drops, it is equal to the kinetic energy of the stone before it hits the ground. So now kinetic energy which I told you that is equal to half mv squared. So it is this velocity we can find. So now kinetic energy becomes this. So we'll substitute here, there will be 1200 is going to be equal to 1/2 times the mass is still 4. So put 4 there times v is what we are looking for. So say 1200 is going to be 2 into 4. It will be like 2v squared. So here we want v, so divide by 2, also here by 2, so that one goes. So we'll have 2 into 1200, it will be 600, going to be v squared. So we square root this one, we square root this one. So v is going to be the same answer, which we'll find 24.5 meters per second. So the answer, there was no answer here. So here, let me just clear out this whole thing here. A machine with a velocity ratio of 6 requires 800 joules of work to raise a load of 16 kg through a vertical distance of that. Find the mechanical advantage of the machine. Okay, so the such question is a bit tricky. A machine with a velocity ratio of that requires 800 joules of work to raise a load of 60 Newton through a vertical distance of that. Okay, then they're saying the mechanical advantage of the machine is, okay, so here we need to find the we have been provided with what mechanical advantage. So a machine with a velocity ratio of 6. Okay, so velocity ratio, remember velocity ratio is equal to distance moved by effort over distance moved by load. So we are told velocity ratio is equal to 6. Then requires 800 joules of work to raise a load of 60 through a vertical height of that. Okay, let me just think of this question. It's quite somehow tricky. So I mean, a simple a machine with a velocity ratio of 6 requires 600 joules of work to raise a load of 60 kg through a vertical distance of that. Find the mechanical advantage of the machine. Okay. So now this one, you see, velocity ratio is equal to distance moved by effort over distance moved by load. So we know that distance moved by effort is equals 800 joules of work. A machine with a velocity ratio of that requires 800 joules of work. Okay, so this 800 joules of work to raise a load of 60 Newton through a vertical distance of 1 meter. So okay, so this question can be only tackled through this method. So we use efficiency method. So efficiency is going to be equal to work output over work input times 100%. So if they are saying a machine with a velocity ratio of 6 requires 800 joules of work. So this one becomes work input. So work input is going to be 800 joules, okay, to raise a load of 60 Newton through a vertical distance of that. So now this load that will be raised through a vertical distance of that will give us work output. So work output now is almost going to be equal to potential energy, because this is the vertical distance, be potential energy, which is going to be equal to mgh. So this will be the mass 60 kg times 10, which is the acceleration due to gravity plus height distance of 1. So this is going to become 60 times 10 times 1, 600, okay, Newton, okay, joules, I mean. So now we have worked out. So this will be the work output. So it is now going to be work output, work input, I mean work output is this one, 600, okay, joules over work input, I said it is 800 joules, then times 100%. So now this now is going to be like this. So where is it? So some questions are quite tricky. You need just to think, to make the brain think. So 600 divided by 800, it is going to be what? 7.5 points, okay, times 100, okay, So that will be our answer, 75. So now in this case, we have found that efficiency is now, okay, let me put here, efficiency is 75. Now, what they are asking us is mechanical advantage. So now we use a different formula. So efficiency is equal to mechanical advantage over velocity ratio times 100%. So now efficiency will be 75. Mechanical advantage is what we are looking for over velocity ratio. We were told it was 6. So put 6 times 100. So now we'll start dividing. 100 goes out in advance. This is 100%. So it will go out in advance. Even here 100, because this was 75%. So that this will cancel. So here we have 0.75 is going to be equal to mechanical advantage over 6. So here now, let me push it here. 0.75 is equal to mechanical advantage over velocity ratio. So now we'll make mechanical advantage the subject of the formula. So we'll say over 1. This times that will be equal to mechanical advantage is equal to, oh, velocity ratio is 6. Why have I put that one? So velocity ratio here is 6. So let me quickly place 6 here. So 6 times 7, 0.75. So I'll get 6. 6 times 0.75, which will give me 4.5. So mechanical advantage will be 4.5. It has no units, which means our answer is C. Quite a tricky question, guys. You're seeing, so quite a tricky question. So now here we come to 7. The common understanding of energy conservation is that it can be transformed from one form to another. Yes. It remains the same in all forms. No, it can be destroyed. No, it can be created. No, energy can be transformed from one form to another. Let's move to the other question. So here 8, the higher an object is from the ground, the higher, the more potential energy it has. Yes. Then we come to this one here, which came on 16th July. What is meant by a moment of a force about a point? So a moment of a force about a point is the turning effect of a force about the point. So you say it is the turning effect of a force about a point. Correct. And then being moment of a force about a point depends on 2 factors. What are they? So moment depends. Remember, moment is equal to force times distance. So it depends on force and the distance. So it depends on 1, force, and then 2, distance of force to the pivot. That's all. Then C, they're saying figure 3.1 shows a uniform meter rule which is pivoted at the 20 centimeter mark and balanced horizontally by an object of weight 3.15 Newton placed at the 10 centimeter mark. Okay, so guys, this one is going to be, I think, the last one. We have done a lot. So let me see this side. Okay. Okay, I'll finish also even this one. Then we are going to continue later. Then here, not here. They're saying, they're saying calculate the weight of the rule. So the weight, I told you, it acts through the center. So this will be the weight. So using the moment, this side will have force on the left times the distance on the left is going to be equal to force on the right times the distance on the right from the pivot. So here we have been provided force as 3.15 times the distance of this force from here. So it will be like 20 minus 10. It will be 20 also here. I mean 10 centimeters here. Okay. So we'll say times 10 is equal to, then from here to here to be like 50 minus 20, it will be like 30. So here it will be like 30 centimeters. So it will be like this weight F will change it to weight times 30. So I'll multiply this times this, it will be like 31.5 is going to be equal to this times that, it is going to be 30 W. Then we want W divided by 30, also here by 30. Okay, so that goes, so W is going to be equal to, so we'll have come on a calculator, so that we'll say 31.5 divided by 30, which will give us 1.05. So it will be 1.05 Newton as the weight. Then we'll come to this one, which says figure 4.1 shows a stone of mass 2 kg, which drops from the top of a cliff and it takes 2 seconds to strike the ground. Acceleration of free fall g is equal to 10 meters per second. So there's a stone here up the cliff, then it is going to drop to the bottom here, like it is now at the bottom. Then they're saying, A, name the form of energy possessed by the stone before it falls. So the energy it has before it falls, because it is raised above the ground, it is potential energy. So you say potential energy. Okay, then here you come. Determine the height of the cliff. So now this height of the cliff will come from a different formula here, because we are told shows a stone of mass 2 kg, which drops from the top of a cliff and it takes 2 seconds to strike the ground. Acceleration of free fall is that. So remember, there's that formula which says height should be equal to ut plus half. If you're not mistaken, guys, I think this formula is still vivid in my brain. Half times acceleration due to gravity times t squared. Okay, let me just see in one of these books here if we can just catch it quickly. So let me do like this. Okay, even like that, I'm still going to catch it. So let's see, where are we? So let's come here and let's have this book here. Let's see, are we going to have it in this book? Okay, let me just go to which one. I think this one. Sleepy piece. Okay, so let me do like this. Okay, yeah, so this is the formula I'm talking about. Okay, so these formulas must be in your brains, guys. So this is the one. So when they say determine the height, this is the formula we are using. Now, if this is going to drop here, it means this initial velocity will be 0, okay, meters per second. Then g is always given as 10 meters per second square. Then time, we have been given time. If you check here, time was 2 seconds. So their time is going to be 2 seconds. So we'll substitute. So it will be like height is going to be equal to, this one is 0 times time, which is 2, plus we will have half times this g will be 10. So put 10 times this t again is time, which is 2. But since it is squared, you square it. So meaning it is going to be h. This times this, it will just be 0 plus. Then here you can even say 2 into 10 in advance, which will be 5. Then times 2 to the power 2, which will be like 4. Okay, so it will be like this is 0, 5 times 4, which will be like 20 meters as the height, 20 meters, if you have not made a mistake. Then see the saying calculate the kinetic energy of the stone when halfway down. So kinetic energy of the stone halfway, it is going to be equal to potential energy halfway. So kinetic energy halfway is going to be half potential energy. So which is going to be equal to half potential energy times potential energy is equal to m gh. So meaning at the middle here, we mean at the middle here. So it's as good as dividing the height, which is 20, divided by 2, which you get as 10. That's what I'm doing in fact here by putting these two here, half. So half times the mass of the stone, if you check, it is 2 kg. So we'll put here mass 2 times 10, g is 10, right? Then times h is 20. So this and this, I think they'll cancel. So just have like 10 times 20, which will be like 200, okay, joules. So that will be the kinetic energy. So it will be like 200 joules, if not mistaken. Then here the final velocity of the stone as it strikes the ground. So the formula for the final velocity, either you say final velocity is equal to u squared plus 2gh, if you remember, or it will be v is equal to u plus gt. I think the answers should just be the same. So let's see if we can find the answer using this same formula. So v squared is going to be, this u is 0 plus 2 times g is 10 times height it moved is 20. Okay, so we are going to have v squared this times, okay, let me start with this times that, it will be 200 times 2, 400. Okay, then square root here to cancel out that, even here square root. So v is like going to be like square root of 400 is like 20 meters per second. Then if we use this one, it is going to be initial velocity is 0, okay, plus acceleration due to gravity is 10 times time. We are told it is 2 seconds here, all right, 2 seconds. So we substitute 2 here. So it's like this is 0, 10 times 2, it will be like 20. So meters per second. So whatever formula we use, the answer is the same, 20 meters per second. Okay. Yeah, so I told you that I'm now going to end here so that the video won't be long, so that I can also have time to rest, guys. Okay, as for now, guys, bye and see you in the next revision.